In this video, I'm going to go through a couple parts of the 1-2C lesson, which is word problems involving variables on both sides. I'm going to look at number 1. I'm going to set up this word problem and then make sure that you fill out all parts of this lesson. I'm not going to go through solving this and answering the following questions, so make sure you do that. So this first word problem gives us a scenario that we are going to invite some number of guests G, that there's 2 places that these people are considering, which is Boondocks and Raging Waters. And the last bit of info is that we are going to set these equal. We'll have to somehow clue people into that in our word problem. So let's write a word problem. You can write your own or you can use the one I'm going to do. Let's do the cost of and we already know it's a birthday party. Birthday party at Boondocks is $60 plus $8 per person. So there's a flat rate. This would be the flat rate here. And there's also the per person rate. And now I can't edit my text box. There we go. Okay. The cost of a party at Raging Waters is $20 per person, and there is no flat fee there. So the question is, if we're setting these equal, then we're saying that the costs of these 2 things would be the same. So we're going to say then, for how many people would the cost be equal or the same at Boondocks and Raging Waters? So we have to make sure that we ask a question and also clue them in to set these equal. They don't know if they should be setting them equal. Let's look at the next one, number 2. So answer all those questions, solve that. Number 2 is a coin problem. So we see some things here. We have quarters, 5 more nickels, half as many dimes as quarters. Left side of the equation looks pretty standard. Right side we have the number of dimes, and we're going to increase that by 275. So let's see if we can craft that one. We want this to sound like a word problem as well. So we'll say something about Jackson has 5 more nickels than quarters and half the number of dimes as quarters. So we'll just hit all of the 3 let statements. Then we'll say that the sum of the value of so we're basically talking about the left side of the equation, so the value of the quarters and nickels is equal to the number of dimes increased by 275. So it's equal to $2.75 more than the value of the dimes. How many of each coin does Jackson have? We need that question as well, which is probably to solve for all the missing information. Let's double check that we did this correct one more time. So the sum of the value of the quarters and nickels is, so that would represent our equal sign. And so we can see that that is the left side of the equation when it was built here. And it's equal to 275 plus the value of the dime. So that looks correct. So I got a couple more. Again, you're going to answer all these questions, actually solve that out. Let's look at number 5. Number 5, we'll just do the setup and you will solve these. The enrollment in dance classes, currently 80 students, is increasing at a rate of 4 students per term. The enrollment requires 120 students and decreasing at a rate of 6 students per term. After how many terms will the number of students in dance equal? This is just like the Boondocks one. the number of students inquire. How many students will be in each class? So we'll put number of dance class students. So this starts at 80 and increases at a rate of 4 per term. Inquire starts higher but goes down 6 per term, where t, I have to define this now because I put this variable in here. So t would be the number of terms. And we want to know when they're going to be equal. So what we're going to do is we're going to set these equal and solve. And unless this is a trick question, we should not get a negative answer. Probably not a partial number of terms, although I guess that is possible. And then it also asks you to plug these back in and find out how many students there will be in each class, which should be the same amount, which is basically causing you to check your work. So I'm just doing setup on 5. 6 was actually a problem that you did last year, so I'm not going to do that one. Let's look at the last two on the last page. Age problems seem to trick people. Jackson is 8 years older than Sam 3 years ago. Jackson was twice as old as Sam was then. How old is Jackson now? So we're going to write out Jackson's age now and Sam's age now. This is critical. Whenever we do age problems, we usually focus on defining the variable of somebody's age for their current age and not in the future or in the past. So Jackson is 8 years older, so we're going to increase then Sam's age, so we'll have Sam be some variable m and Jackson be n plus 8 or 8 plus m. And now we're going to write out our equation, which is 3 years ago, Jackson was twice as old as Sam was then. So Jackson's age, and we're going to say that that's equal to double what Sam's age is. And we also need to do 3 years ago. So we're going to reduce this age by 3. And we're going to take Sam's age, reduce it by 3, and then double it. Because we want to double Sam's age 3 years ago. We want to make sure that these parentheses are separating or including the minus 3 portion, that is not outside. Okay, there's our equation for number 7, and I'll let you solve that. And let's look at number 8. Number 8 is another coin problem. This one we actually saw, I believe, in the section 1.1 review or something very similar to it. It says a box contains 30 coins. Some of the coins are nickels and the rest are dimes. The total value is $2.40. So number of nickels, number of dimes. So we need to pick a variable for either of these. It doesn't matter which one. So let's say we call this n. And let's just pretend that there are 10 nickels. That would mean that there are 20 dimes. Or if there were 5 nickels, there would be 25 dimes. So that would mean then the number of dimes is 30 minus n. That's where we're getting these missing values. And that would then mean that our setup for this, so we're going to set it equal to $2.40. There's actually not going to be variables on both sides of this equation. 5 cents times the number of nickels plus 10 cents times the number of dimes. And this will get us our answer. So in this video, I just went through some of the more challenging parts, which was the setup of a couple problems as well as writing a couple of the problems. Your job is to finish the lesson, and the key will get posted in Google Classroom.